In this unit, we're going to be talking about rational expressions, and in this section today, in particular, multiplying and dividing rational expressions. So, a rational number is a fraction. And a rational expression is an expression that can be written as a fraction, p over q, of two polynomials, p and q, as long as q does not equal 0. A fraction is undefined when the denominator equals to 0. So when you have 5 divided by 0, this is undefined. A rational expression is also undefined when the denominator is equal to 0. So we'll talk about the domain of a rational function. And the domain of a rational function will be all real numbers. So it will always be all real numbers except any value of x which makes the denominator equal to 0. So example 1, find the domain of each rational function. So for A, it's going to be all real numbers except what makes the denominator equal to 0. Well, 2 will never equal 0, so this will always be just all real numbers. There's no exceptions. B, on this one again, I'll have all real numbers, so all real numbers. But this time, I do have a denominator, x minus 1, and I can ask, where does that equal to 0? And I'm going to add 1 to both sides and get that x is equal to 1. So for this one, the domain is going to be all real numbers except x equal to 1. So x can't be 1. Notice if I put a 1 in, I'm going to get up here, I get a 5 minus 3 is 2, and then 1 in here will give me a 0, and 2 divided by 0 is undefined. For C, again, it's going to be all real numbers, and I need to figure out when this denominator is equal to 0. So where does x squared minus 2x minus 15 equal to 0? I'll need to factor that with the AC method. So x minus 5x plus 3. So that will tell me that x minus 5 is equal to 0, so x is equal to 5. X plus 3 is 0, so x is equal to negative 3. So the domain for C is going to be all real numbers except we're going to say that x can't be 5 or negative 3. Now we're going to be simplifying and writing rational expressions in lowest terms. So step 1, we're going to completely factor the numerator and the denominator of the expression. And then step 2, we're going to divide out factors that are common to the numerator and the denominator. So example 2, the numerator is factored. The denominator, when I factor it, it's going to have a GCF of 2x squared. So this would be 2x squared. And when I divide into that, that's going to leave me with a 5x minus 1. And my numerator is 2x squared. So I'm going to look for factors that are common. So they both have this 2x squared here. So these are in common. So 2x squared over 2x squared is 1. So now this is really 1. And this is going to be 1 over 5x minus 1. And when I multiply, 1 times anything, of course, is just that thing. So my answer is going to be 1 over 5x minus 1. B, I will need to factor both of those with the AC method. So I'm going to stop this, and I'm going to do my factoring to the side and then come back. Voila, my factoring is done. So my numerator factors into 9x minus 4 times x plus 1. So that multiplies to be that. And the denominator 8x minus 7 and x plus 1. So I'm going to divide out common factors so you can see how this set of parentheses, x plus 1 over x plus 1 is going to be a 1. So that's going to cancel. It's going to divide out and make a 1. And so I will then be left with 9x minus 4 divided by 8x minus 7. Neither one of these can be factored, so this cannot be canceled anymore. So in order to cancel, or in order to remove these factors, it has to remove to be a 1. So they have 1 times that, and I'm left with this.